All right, welcome to The Explainer. Today we're tackling, well, maybe the biggest mystery there is, consciousness. We're going to walk through a radical new blueprint for understanding it, one that really flips the old way of thinking completely on its head.
So let's just get right to the heart of it. You see, it all comes down to this one huge question. It's not about how a brain processes information. I mean, we're getting really good at figuring that part out. The real puzzle, the thing that keeps scientists and philosophers up at night, is why all that electrical and chemical buzzing has an inner life attached to it. Why does it feel like anything at all?
And this isn't just some, casual head scratcher. It's a question so profound that it's actually earned its own special name. It's called the hard problem of consciousness. And really, getting a grip on what that means is the first step for everything we're about to explore today.
So what the hard problem really does is it shines a spotlight on this massive gap between the physical stuff, the neurons, the synapses, and our inner world. You could map every single neuron firing in a brain as it looks at a beautiful sunset. But that data, all those charts and graphs, it tells you absolutely nothing about the feeling of seeing that sunset. That feeling, that subjective quality is what philosophers call qualia. It's the sting of a paper cut, the warmth of the sun, the specific shade of blue in the sky. It's literally the what it's like to be you.
Here's a simple way to think about it. A computer, right? It can analyze the exact wavelength of red light. It can process it, categorize it, spit out the data. 700 nanometers, check. But it doesn't experience red. It doesn't see red. A brain does. And that jump, that incredible leap from just raw information to an actual subjective experience, that's the canyon that we've been trying to figure out how to cross for centuries.
Okay, so faced with a problem that big, where do you even start? Well, the framework we're looking at today suggests we do what science has always done when it gets stuck. We look for an analogy. We look for another impossible problem that we actually managed to solve. And for this, we're going to turn to something we all take for granted: gravity.
And here is the big pivot, the huge what if. What if consciousness isn't something the brain makes, like a factory produces a car? What if, like gravity, it's just a fundamental property of the universe itself? Think about it. Gravity isn't something that a planet emits. It's the property that allows mass to have weight. So what if consciousness is the same kind of thing? The fundamental property that allows a sufficiently complex system to have an experience, to feel like something.
And look, this isn't just some wild idea. This is exactly the kind of big picture shift in thinking that has happened before in science. For hundreds of years, everyone thought of gravity as this mysterious, invisible force pulling things together. And then along comes Einstein, and he just completely reframes it. He says, no, it's not a force, it's just the shape of reality. It's the curvature of space-time. The framework we're exploring today is basically saying that consciousness is just waiting for its own Einstein moment.
Okay, so before we dive into the math, and don't worry, there is math, but it's cool, I promise, we really need to get the philosophy behind this thing. Because this isn't being presented as the one true answer. It's designed to be something much, much more useful than that.
The guiding principle here is a famous saying, the map is not the territory, and that's exactly what this is. It's a map, a tool designed to help us navigate this incredibly complex landscape of consciousness. It's meant to be useful, to help us ask better questions, but it's not trying to be a perfect photograph of reality. And that whole map, not the territory idea, leads to a really different kind of approach. First off, it values what works, It's all about functional utility. And instead of trying to compete with all the other theories of consciousness out there, it actually tries to integrate them, to see them as different parts of the same big picture. And maybe most importantly, it honors your own individual subjective experience as a valid piece of the puzzle. The goal here isn't to shut down the debate, it's to blow it wide open.
Okay, to make this whole model work, we have to get really specific about one key word: awareness. In this framework, awareness is stripped way, way down. I want you to think about your eyeball for a second. Your eyeball is aware of photons, right? It's in a state where it's ready to receive that light information. But the eyeball itself doesn't comprehend sight. It doesn't know it's seeing a cat. It just receives and transmits. And that fundamental receptive state, that pure input without any interpretation, that's what this framework means by awareness.
All right, this is where it gets really interesting. This is where the philosophical rubber hits the scientific road. How do you take a beautiful analogy like gravity and actually turn it into a model you can test and work with? Well, you do what physics has always done. You translate it into the universal language. You translate it into math.
So first we start with a kind of Newtonian model for consciousness. On the left, you've got Newton's law of gravity. We all kind of remember that from school, right? And on the right, you see an equation that is structured in the exact same way. But instead of predicting the gravitational force between two masses, this qualia attraction law tries to predict the subjective intensity, the qualia, between two interacting hubs of information. It's a direct one-to-one parallel.
Okay, but now for the big Einsteinian leap. Because just like Einstein took Newton's idea of a force and completely reframed it as the geometry of space-time, this model proposes we do the exact same thing for consciousness. It suggests that the intensity of an experience, that feeling of joy or sadness or pain, it isn't some weird force that the brain just spits out. No, it is the curvature of a fundamental consciousness field, a field that gets warped by the density and flow of information. So in this model, feeling isn't some ghost in the machine, it's literally part of the fabric of reality itself.
Now, of course, a map this new and this radical, well, it's also going to have a lot of blank spots on it. This is absolutely a starting line, not a finish line. And, in that spirit of being a useful framework and not a rigid dogma, it's super transparent about the huge questions that are still out there.
And yeah, these are the heavy hitters. Like, how exactly does a universal field like this interact with a physical brain? How can we design experiments that could actually prove this model right? Or, just as importantly, prove it wrong? But see, these aren't seen as flaws in the map. They're the parts labeled "Here be dragons." They're an open invitation for the next generation of scientists and thinkers to come in and help fill in the blanks.
So this whole thing leaves us with a really big, kind of mind-bending final thought. What if, for all these centuries, we've just been asking the wrong question? What if we stop trying to explain how a bunch of dead matter somehow magically creates this thing called consciousness, and instead, we start from the assumption that consciousness is just a fundamental property of the universe, like gravity or electromagnetism? What would change? What might we discover if we finally started looking for it everywhere?